Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, we're discussing electrons. Electrons are the most important part of chemistry. They are the glue that hold atoms together. A chemical bond is a shared pair of electrons, and when chemical reactions occur, it's because the molecules are changing the way that the electrons are distributed amongst them. Batteries provide power to devices by moving electrons, and most of the time when you see color, it is because of photons interacting with electrons. Not to mention then the interaction when the photons reach your eyes, releasing more electrons into your body which is also powered by electrons. So what about these other parts of the atom you've probably heard of? Protons and neutrons. Well, these are important as they comprise the atom's nucleus, but what they're really doing is they are providing a place for electrons to hang out. You can think of it as being like in a city where you've got the buildings, which are the nucleus, your protons and your neutrons, and the people going about making things happen. Those are your electrons. And just like people are very small compared to buildings, electrons are incredibly small when they are compared to the other subatomic particles, the proton and the neutron. In fact, if the electron had the same mass as the average person, then a proton would weigh the same as 3 average houses. If we continue at this scale, then the Eiffel Tower would have the same mass as the nucleus of germanium. I know, unfortunately it's not francium, but that would take 3 Eiffel Towers to reach that atomic mass. Being so small, it's natural to wonder, how did we discover the electron? Well, near the end of the 19th century, the English scientist J.J. Thomson is investigating cathode rays and the cathode ray tubes that contain them. And he comes to realize that these cathode rays aren't some special wavelength of light, but rather they are charged particles. He estimates them to be about 1,000th the mass of a hydrogen ion, which was the lightest known charged particle at the time. You see, electrons are negatively charged, and in a cathode ray tube, there is a negative end and a positive end, and so the electrons get accelerated through the tubes. Electrons are very light, so they can get up to very high speeds and have a lot of energy, and when they strike something, they can impart that energy into it, and that thing might just glow. This is how cathode ray tube televisions worked. We fired electrons, they hit phosphors, and we saw light. But to get them to the right place, we use a magnetic field to bend them. And this is what J.J. Thomson was doing. He was applying a field to the cathode ray, and he observed that it was bending. And the stronger the field, the more it bent. Another way to think about this is the more massive the particle, the less it would bend. And this is how he was able to come up with a mass-charge ratio, by knowing how much force, how much he was bending, and how much mass there must be in that electron. The discovery of the electron revolutionized atomic theory. The prevailing wisdom at this time was that either atoms were the smallest part of an element, and different elements had different types of atoms, or there could have possibly been some fundamental building block that went into making an atom, but it would have been about the size of a hydrogen atom. There was no concept that there could be something this small and this important. So J.J. Thomson came up with the plum pudding model. This idea that you had a positively charged sphere, which was your main part of the atom, and dotted throughout were these negatively charged electrons. This model would later be disproved by Ernest Rutherford, but that is a story for another time. Thank you for watching this video. If you've enjoyed it, please make sure to click that like button and subscribe so you know when future videos come out. Or if there is a specific topic you'd like to see covered in a future video, please put it down in the comments below. Thank you.